Welcome to the first video in the Intermolecular Forces series about dispersion forces. There'll be a couple more videos, one on dipole and one on hydrogen bonding, but for the moment we have dispersion. So, before talking specifically about dispersion, let me just point out a couple things about the concept of intermolecular forces. First, if you look at the word intermolecular, inter as a prefix means between. So what we're really talking about here is forces that exist between molecules, intermolecular. Just as a quick example, here are two carbon dioxide molecules. Now, the intermolecular force is occurring in this vicinity here, between the two molecules. This would be true of anything. So any two molecules will have some amount of intermolecular force between them. So what we're specifically talking about is a kind of intermolecular force called dispersion forces. Dispersion forces are all over the place. Dispersion forces are caused by random motion of electrons. Since all molecules have atoms and all atoms have electrons, we could say that dispersion forces are experienced by all molecules. You're going to find that dipole and hydrogen bonding are experienced by some specific molecules. Dispersion forces are kind of a baseline for all molecules. Trying to explain what a dispersion force is a little tricky, especially in this medium. But if you notice, so dispersion forces being caused by random motion of electrons. One way that we describe dispersion forces is as momentary poles. In other words, if you consider any molecule, there's a lot of electrons moving around there very chaotically. Moment to moment, due to that random chaotic motion, you might have small buildups of electrons in one area or small deficiencies of electrons in an area. That's going to provide, in that moment, a particularly charged pole. Moment to moment it changes. These forces are very weak. They're the weakest of the three intermolecular forces we're going to look at. So to recap, first, dispersion forces are a particular kind of intermolecular force, which by definition means that it occurs between molecules. They're also considered the weakest intermolecular force, but they're experienced by all molecules. So dispersion forces are experienced by any molecules by virtue of the fact that all molecules have electrons. And lastly, we mentioned that one way to think about a dispersion force is that it's a momentary charged pole, moment to moment. This is fraction of a second to fraction of a second. The nature of the dispersion force is going to change because electrons are in constant motion. So these four items are really the take-homes on dispersion force. And check out the next video, which is on dipole forces.